Hi everyone, welcome back to my number sense series. In this video, we're going to be talking about prime factorization. Now, prime factorization is not only for this video, but for basically all of number theory. It has applications in finding the number of divisors that a number has, finding the sum of all of its divisors. Prime factorization also tells you a lot about a number. And so prime factorization is a huge important idea in math in general. And so the question is, well, first of all, what is prime factorization? Well, you might have heard someone refer to prime numbers as the building blocks once. Kind of like atoms, how atoms make up everything for us. Prime numbers can kind of be multiplied to make everything else. For example, 30. 30 is equal to 2 times 3 times 5. There is a theorem that says every number can be broken down into a unique product of prime numbers. And this product tells us a lot about the number. And so often we would like to learn how to make this product. Of course, going from the product to the original number is very easy, but going from the original number to the product is going to involve some guesswork. So when we do prime factorization, we like to try to make the number small as fast as possible. And that would usually involve starting from the smallest prime factors. So 2, 3, 5, 7, 11, 13, and so on. So for example, if we were to try to prime factorize the number 60, this is how we would do it. So 60, you would have to test the smallest primes first. So first of all, let's test 2. Does 2 divide into 60? Yes. So it's 2 and 30. And we use this diagram sometimes to help us think about it. Now, think of this like the end of a branch, so to be called, as a leaf. At the end, we're going to multiply all the leaves to find the prime factorization. Now we need to prime factorize 30. 30 is once again a multiple of 2, so it becomes 2 and 15. Then this 15 splits into, well, not 2, but the next smallest prime, 3, works, so it's 3 and 5. And so we know that 60 is going to be equal to 2 squared times 3 times 5, just multiplying all of these primes. And these are like the smallest building blocks that make up the number 60. Now in future videos, we're going to learn how to use this prime factorization and other prime factorizations to determine how many factors a number has. But for now, that is not the important part. We are just trying to learn how to prime factorize. So another example might be 252. If we were to try and prime factorize 252, here's how it would go. First of all, you might notice that it's divisible by 2 or 4, but let's just say 2. So when we divide it by 2, we get 126. Now, if we want to prime factorize this, we have to think about it. Okay, it's also divisible by 2. That's 2 and 63. Now, 63 isn't divisible by 2, but it's divisible by the next smallest prime, which is 3. So 3 and 21. Then 21 is also divisible by 3, so it's 3 and 7. And we notice that 7 is also a prime, so we've decomposed this number as well. And it's equal to 2 times 2 times 3 times 3 times 7, which is going to be equal to 2 squared times 3 squared times 7. And that is how we prime factorize. Now, the basic number theory questions in number sense are going to basically just ask you, what's the smallest prime divisor? What's the greatest prime divisor? And really, these are pretty easy to do because oftentimes it's going to be kind of a gimmick number or just a number that is either small or easy to divide. For example, 7171. If you remember our other videos about multiples of 101, this is extremely easy because, as we recall, multiplying a number by 101, let's call it AB, times 101 equals just AB. For example, 23 times 101 is just 2323. And so we can just tell that 7171 is going to be 71 and 101. Now we have to see if these two numbers can be broken down more. Now here is where we should memorize our primes. If we have our primes memorized up to 100, this is very easy. And if we have our primes memorized up to and including 101, because yes, 101 is prime, this becomes even easier. Because we can tell that these are both prime numbers, and so we just look for the least prime divisor, which is going to be 71. Now similarly, this question asks us about 9191. So using similar logic, we can see that 9191 can be decomposed into 91 times 101. And so the answer is not 91, because 91 isn't prime. This is something a lot of people get wrong. 91 is the number that is most commonly mistaken as a prime, but in fact it's not, because it's 7 times 13. So this number is actually equal to 7 times 13 times 101, and now we know that 7 is prime, 13 is prime, and 101 is prime, so we can look for this least prime divisor, which is going to be 7. Now, not every number is going to be repeating and a 4-digit number. We can have 2125 or 114, but we have ways of dealing with those as well. For example, look at this, 2125. What do you notice about this? Well, you can notice two things. Either it ends in 125 or it ends in 25. Personally, I think ending in 25 is just more common to notice, so I'll go with that way. Now, if you notice that this ends in 25, this should spark some recognition in your brain as well. This is kind of like our multiplication tricks in reverse, because what's our trick for multiplying by 25 involved dividing by 4, and then at the end adding 25 times the remainder. And it's possible that that remainder could be 1, and we would end in 25. And so we can tell that this number is going to be divisible by 25. But the question is, it's 25 times what? Well, let's kind of try to reverse engineer the process. If we were multiplying a number by 25 and we got 2125, what would that tell us about the number? Well, it would tell us that the number is 21 times 4, because when we divide the number by 4, we would have gotten 21 with a remainder. So the number is 21 times 4 plus a remainder. Well, if the last two digits are 25, that must have meant the remainder was 1. So our original number was 21 times 4 plus 1 equals 85. And so 2125 is equal to 25 times 85. Of course, this is not in prime factors. 25 is 5 squared, and 85 is 5 times 17. So this is actually 5 cubed times 17. And yes, if you recognize that this actually ends in 125, you could have recognized that this is actually 125 times 17, which leads directly to this conclusion. But I went this way because I think it's more common for people to recognize the 25. So this 5 cubed times 17, 5 and 17 are both prime, so we have finished this prime factorization, and so we can say that the greatest prime divisor is going to be 17. Now the last question is nothing special, but it's a smaller number, and that makes things very easy, because to prime factorize 114, here's what we have to do. Just execute the same algorithm. Look for the smallest prime. Well, the smallest prime is 2. Does 2 divide 114? Yep. So 114 becomes 2 and what? 2 and 57. Now, of course, 2 is prime, so we decompose 57. What does 57 become? Well, it's not divisible by 2, but 5 plus 7 is 12, so it's divisible by 3. So it becomes 3 and 19. Is 19 prime? Yep. So we have our prime factorization of 2 times 3 times 19. And now, it's very easy. We can just look for the greatest prime divisor, which is going to be 19. So that is an introduction to prime factorization. Now, this is a super important topic. I think it's super important to get good at prime factorization. Just keep practicing it. Keep dividing in your head, going through this algorithm of maybe recognizing special things about the numbers or just dividing primes, because this is going to be very important for the rest of the videos that we do in number theory. So I hope this video was helpful as an introduction. That's going to be it for today. Thank you guys so much for watching, and I'll see you next time.